Okay. Right. Gauri, has you connected to your system?
Yes, sir.
Okay, okay. So let us start. So now close your schematic editor and all those things. Keep only library manager. Okay. So keep only library manager here. Close all of the things. If you want to save a state, you can save state. No issue. Okay, open the library manager. PC number 7, close your schematic editor.
Sir, I need to open the library manager, no?
No, that is on the bottom side. Maybe you can observe that. But you need to close the schematic editor, previous schematic. Otherwise, it will create a problem for a new design. You just close it. Yeah, good. Yeah, so be here only. All the waveform window should be closed and all the schematic editor should be closed. Only library manager you keep open, okay? But don't quit Xilinx main, Cadence main window. Okay, so be here. So now we are going to do the parametric analysis of N MOSFET and P MOSFET. So what is mean by parametric analysis? Okay. So as you know, if I consider N MOSFET, right? So if you draw ID versus VDS characteristics for this, okay, by changing the VGS, so you can observe IV Cara like this, right?
Yes,
Okay.
sir.
For a different value of VGS, for example, 1.5, VGS 0.5, like that way, some for values, okay? So these are the drain current values, right? Now here you can see this x-axis is VDS, okay? For example, if the maximum voltage is 1 volt, so this will be vary from 0 to 1, okay? And if you consider the VGS, if you vary from 0 to 1.5, okay? So we should get such a kind of IV curve, right? Okay, for a different value of VGS and for a different value of VDS, we are getting different value of ID currents. So in this, now you are familiar with this characteristics, right? Okay. So generally, this part we call as a linear region, right? Or triode region.
Yes, sir.
And this part we call as the saturation region. So if your MOSFET works in the saturation region, you can use that MOSFET as an amplifier, right? So it will work as a constant current source. And if you use your MOSFET in linear region or triode region, it will act like on switch, right? Variable resistor. Voltage dependent resistor, right? Okay. And if you see the cutoff region, so there your MOSFET will be in the off condition. So this is a general IV Cara of AN MOSFET, right? So using a Cadence virtuoso tool, I need to plot this IV characteristics. Okay. So for different values of parameter, I am getting different values of drain current. Okay. Such a kind of analysis is called as a parametric analysis. Okay. Changing one parameter changing more than one parameters and observing the effect on the dependent quantity. Okay. So like that way we need to plot this. So to do this, now you have created your library, keep as it is only, but in that library you need to create one cell. Okay. In this cell we will do the parametric analysis of n MOSFET. So I will go to file, new, and cell view. Okay. So new file ready is get pop up, right? So now here I will give the cell name nmos para. Okay, nmos underscore para. So here view should be schematic, type should be schematic, and open with schematic L. You just check that. Okay. Don't give the name. Only give the relevant name like nmos parametric analysis. Don't give the inverter parametric analysis. Give the nmos. Okay. Cell view. Rahul, cell view. Rahul, not a library. Cell view. File, news, cell view. Okay. Now if you click on OK, schematic editor will open, right? Sir, उसको बता. Rahul, on the bottom side, new file window is opened. Here you can give the name and click OK. Then schematic editor will open. Okay, so if I want to do the parametric analysis of n MOSFET, so I will type I, so instance will open, or you can create from this also, create instance. Okay. So your library is GPDK 90, GPDK 90 only, na? So from that, select NMOS, the first one. So whatever the technology of your library, that should be the library of MOSFET. Okay. ठीक है. So after doing this, place it in schematic editor.
Sir, can you repeat the steps for add instance?
Yeah, you select first NMOS 1B. Okay, GPDK 90. Hide this and place it. Okay. So I need to connect voltage sources to this. So as you know, voltage sources are available in analog lab. So I will take two DC voltage sources, VDC, type I. Select the library analog lab. And here you type VDC. Select that VDC. Hide this. Now place two VDCs, two sources, one here and one here. Okay. Escape. Now take a ground. Again type instance I, and instead of VDC type G and D. Ground. Take a ground. Okay. Now make a connection how I show it, like that. make sure that body terminal is connected to the source. Body terminal, middle one. Okay, Rahul. One time you click it, then move the wire. One time click and move the wire. Then move the mouse. Okay, all of you have done the diagram. Okay. Okay, we are waiting for other fellows to complete. Rahul, connect the body terminal to source. Middle one.
This one.
Okay, so after connecting the circuit diagram like this, schematic like this, just do the check and save. And check it is showing some errors or what. Okay, so you don't want any error. That Poonam is got the error, right? नहीं आया नहीं राइट है कनेक्ट किया है ना वो क्या एरर दिखा रहा है और दो सोर्सेस हो गए सर उसमें एक डिलीट कर दो एक साइड उस क्लिक करो उसको मूव कर लो ना एक बार उस पर देखो उसको मूव करके देखो एक बार हाँ अभी उसको साइड में लो नहीं वो एरर का दिखा रहा है देखो है वो हाँ okay Poonam you can do your design now okay
Yes, sir.
ठीक है now we need to change the properties of voltage sources so first I am selecting this source VTS type Q or you can right click okay you can right click and properties so now here instance name I am giving VDS okay okay and I am giving the DC voltage 1 volt okay now press OK and similarly you need to select the input source also input source right click properties I am giving the instance name VGS for an input source okay and voltage 1 volt
Please repeat the steps so that type 1 volt variable.
Okay, done.
Second step.
Okay, so after doing this, do check and save. Okay, so no error are there. Then go to launch ADL.
Everybody go to launch ADL.
Okay. And now select the analysis. Here you can see the analysis tab is there. Choose analysis.
Go to choose analysis.
Click on that. So I'm just selecting the transient for 100 and small n. Okay.
Right, small n.
It is a case sensitive language. So I am selecting moderate mode. Okay. Go slowly, no issue. Then click on OK. Now here you can see transient analysis gets added. Now we need to select a DC analysis. Okay. So for DC analysis, I'm selecting on DC. Save DC operating point. Or one time I will show you transient and then I will show you the DC. Okay. Otherwise I can show you. Okay. Select DC. Save DC operating point. And now here you can see the sweep variable. So all of you are following? Okay, Rahul, go to here, choose analysis. Yes, that window. Select DC there. See, only click DC. I will tell you about other steps.
Click on DC.
Don't click OK, okay? Only जो मेरा विंडो है ना उतना ही देखिए. Now here you can see the Swift variable section is there. Okay. So what is meant by Swift variable? So we need to change, for example, if you see this IV characteristics, here I am changing the VDS from 0 to 1. Okay. So I am sweeping the VDS variable. It's DC value I am sweeping. Okay. DC voltage is getting swept. So for example, if I am giving the step size 0.1 volt, so first I will apply 0, then 0.1, 0.2, like that way I will sweep this variable. Okay. So different kind of sweep variables are there. So you can vary your design with the temperature. For example, if you are designing a chip for a consumer application, right? So for consumer application, the temperature range is different, right? If you are designing a chip for military application, their temperature range is different. And as you know, if you consider this N MOSFET, right? And if you operate N MOSFET in saturation region, the drain current equation is like this. So now in this parameter, this is overdrive voltage, right? This is a width and this is a length. So this thing is called as aspect ratio. So this will be decided by the physical design engineer. Okay. But this mobility of electron and similarly this oxide capacitance will be decided by the physical dimension of the MOSFET. But this mobility of electron is dependent on the temperature, right? So as the temperature increases, what will happen? This mobility will decrease. because of the scattering effect. Okay, carrier scattering effect, right? So drain current will change. So if the drain current will change, for example, if there is one amplifier, okay. So as you know, for an amplifier, biasing will require, okay, to keep the operating point in the particular region. Suppose if I want to operate MOSFET in this region to use it as a constant current source, I need to put operating point into this region, right? So I need to bias this amplifier properly. So for example, if I am using this current source to bias the transistor, and as the temperature will increase, what will happen? Current will decrease and my biasing condition will get changed. Means, for example, if temperature is increased, previously that device will was working as an amplifier. Now it will work like a switch. Okay, open or off switch, on or off switch. Okay, so DC biasing condition will get changed. So other factors are also there, like resistances, capacitances, all those parasitic things will get changed. Okay, so that's why the temperature factor is there. Similarly, design variable, you can sweep the design variable also. What is mean by design variable? So width of the MOSFET, length of the MOSFET, right? So these are the design variables. So you design this variable. If you select any MOSFET here, so it is showing how much should be the width, how many fingers are required, what should be the width of the finger. Okay, so all those things are there. Those things will come under design variable section. Now the third section is component parameter section. So what is mean by that? Whatever the DC sources, input sources you are using in your design to test your design, you can sweep those sources. For example, in this IV characteristics, we are using VDS as a DC voltage source, right? So if I want to observe such a kind of IV curve, I need to vary this variable. Okay, I need to vary the value of this variable. So such a kind of variable come under component parameter. Okay, so we will see this parameter one by one. So first I will select the component parameter. So now if you click on the component parameter, this window will get open. So it will ask you for which component should be varied. Okay. PC number 7, click on component parameter. Okay, and now here you can see they are asking for which component you should want to vary, right? Okay, so I will select component here. Now when you click on select component, what will happen? It will go into the schematic editor. Okay, select component name.
Sir, what to enter in the section of
No, here you can
component
see.
name?
Okay. Now here you can see select component is there, no? So I'm
Yes, sir.
clicking on this select component. Okay. Okay. पता था वो कुछ बच्चे पीछे रह गए. Okay. Select component. If you select the select component, it will come into the schematic editor. And now you can just choose the VDS. Okay.
VDS. All of you choose the VDS.
Select the VDS.
Select VDS. One pop-up will open. Yes.
Now one pop-up will be there. Now they are asking which parameter
Select
you want to vary.
component parameter. Yes, sir.
Yes. So they are asking which component you want to vary: DC voltage, magnitude, phase. Okay. So different kind of parameters are there. So I am selecting the DC voltage because I have only given the DC voltage to that particular parameter. Okay, component. If I click OK, all of you click OK, then select the DC voltage.
Check DC voltage, then okay.
Sir, then
Yeah.
okay.
Okay.
Now come
Now
back
on the
to
bottom side, you can see the choose analysis window.
Go to ADA.
No. Choose analysis. Hmm.
Choose analysis.
On the bottom side, Rahul, choose analysis. Yeah. So here you can see the one component is get selected. Component name is VTS and the parameter name is DC. Okay. Now after that, one window came that is asking for sweep range. Means for what range you need to vary that component value. Okay. So my maximum voltage is 1 volt I am considering here. So I have given the 1 there. So I will sweep VDS from 0 to 1. Okay.
Write the sequence from 0 to 1.
The start should be 0 and stop should be 1. So here you can see if I starting from 0, I need to stop at 1.
Sorry, start from 0, stops at 1. So is that variable?
Okay. Now in the sweep type, you can see different types are there. Means logarithmic. Okay. Logarithmic, automatic, linear. So depending on your design requirement, you can give those values. Okay.
We want linear,
No, we can give any,
okay,
but we need to vary. So I'm keeping automatic, not doing the things more complex. So I'm keeping automatic here and press OK.
All of you press OK.
Yeah, press OK, Mohammed.
Mohammed, press OK.
Now go to the ADE now. Yeah, good. Now here you can see
Sorry, go to AD window.
bottom में आता है वो bottom में. Now here you can see two analyses get added. First one is a transient analysis, so which is varying from 0 to 100 nanoseconds. Okay. And speed of operation is a moderate, means moderate accuracy, moderate speed, simulator speed. Okay. And the next analysis is DC. So it is showing for which component we are doing the DC analysis. Okay. And what are the start and stop range. So whatever you are selecting here, okay, so those all things are case sensitive. Okay, so I have shown you before the lunch time there is an input.scs file. Okay, so that is a netlist file. So this EDA tool, what it do, it collect all these things. It collect all these things like a transient analysis, DC analysis, and in the proper format, and it create one file, netlist file. Okay, and that will be applied to the simulator. So after selecting these two analyses, I need to select outputs. Okay, which output I want to view and which input I want to view. So I'm just selecting setup outputs. Here you can see. Here you can see setup outputs. So click on that setup outputs. One window will get open, right?
Yes.
Setting outputs window. Here, what is her name? Pooja. Poonam, here you can see.
Yes, sir.
Yes. Now here from design option is
Sir,
there.
I have.
Okay, take it.
From design option is showing here, right?
Now here you can see the prompt design option is there. So prompt design means whatever the design we have created, we can select the input and outputs from that design. Okay. So if I click on from design, it will go into the schematic editor. Okay. Click on from design.
Now click on from design.
Okay. Yeah. Take it. Now
from design.
maybe lagging issues. So as I told you, here you can see if you want to measure the voltage, you need to select the net. wire, right? And if you want to measure current, you need to select a node. Now this red rectangles you are seeing now, these all are the nodes. Okay. So this is a drain node. So if you want to measure a drain current, you need to select a drain node. If you want to measure a source current, you can select a source node. Similarly for other components also. If you want to measure voltage, you just need to select net. Okay. So here I am selecting a node because I want to measure a drain current of this MOSFET. Okay. So simply select node only. So are you following? Okay. Simply select node only. Don't select any other thing. Yeah, good. Now here you can see. Okay, PC number 7 got stuck. So hello, are you there? गौरी डिस्कनेक्ट हो गए मे बी ठीक है दूसरे एनालिस्ट बता देंगे ओके आफ्टर सिलेक्टिंग दिस ऑन द बॉटम साइड यू कैन सी सेटिंग आउटपुट विंडो इज देयर सो वन नेट इज गेट सिलेक्टेड हियर not a net, it is a node. Okay,
now click on setting output.
bottom side ठीक है वी कैन डिलीट दैट नहीं सर ठीक है now here you can see the net is node is get created. So nm0 is a component name and D is its terminal. So D means drain terminal. Okay, so if I click on OK and if I open the ADE now, so in the ADE you can see that node is get selected. Now some people have selected more than one nodes maybe. So how can we delete the nodes? Here you can see you need to select that particular signal, net or node, and you need to press this. From there also. You click OK.
Click OK.
Rahul.
Click OK. Connection there.
Actually, it is lagging, sir.
ठीक है चलेगा कुछ नहीं. So you should respond now, so we don't get things right. We are asking for the same thing then.
Yes, sir.
So here you can do the simulation now. Netlist and run. Okay. Click on netlist and run. This green color button.
Okay.
राहुल को बताइए.
Rahul is not online, sir. Rahul, are you online?
Okay.
Yes.
So now here you can see the left one is a transient response window. So which is respect to time. So we run this simulation for 100 nanoseconds. So this is a DC current. So it is only showing the DC current, which is having the value 81.046 microamperes, right? Okay. So transient analysis is with respect to time. And here you can see the right side window is there. Okay. So in the right side window, we have varied the VDS from 0 to 1. And you can see the drain current for that particular thing is varied. Okay. So here you can observe drain current for particular VGS. So here VGS is how much we kept. VGS 1 volt we have kept. So if I select V here, okay. Now you can observe that okay. VV. Okay, for a different value of VDS, what drain current we are getting, right? So this is for only one VGS. Okay. So if you want to plot IV cara, total IV cara, you need to do the parametric analysis. Okay. Now keep this window like this only and minimize this. Otherwise, you can minimize this. Minimize this waveform window. Now go to ADE. So in the ADE, yeah, ADE window. Go to the tools. Now you minimize Poonam.
Here my side it is 4 to
Okay. So here you can go to tools. Okay. Then result browser. Third option. Are you following? Poonam?
Yes,
Here.
sir.
Tools, result browser. Tools and result browser. Have you selected that?
Sir, I am in ADL window.
Yeah, in AD only. Tools, result browser.
Result display.
Result browser.
Yes, sir. Yes.
Click on that. Okay. You
Yes,
can
sir.
run the simulation again if you want to.
Okay, sir.
Now go to the waveform window. Now in the waveform window, you can see that on the left hand side, browser window is get added. Okay. So if I click on this plus sign, okay, and if I click on the DC output info, plus sign of DC output info, okay, now I'm selecting NM0 means and MOSFET. Yes,
Yes.
click on that.
NM.
Now you can drag this screen. Here you can see if this arrow is like this, and you drag it. Okay. Drag it properly. Poonam?
Yes, sir. Doing.
Yeah, drag it. Okay, Rahul. Rahul.
Yes, sir.
You can run your simulation again. Go to the waveform. Don't close the AD. Okay. You can run your simulation again. You make sure that result browser is opened.
Sir, result browser is open. You can check it. This is the result browser. It is loading.
Yeah, that is only open. You click on that. Result browser is also open. ठीक है. For other fellows, I will show you. Okay. So here you can see the different. This is a parameter related to the single MOSFET. Okay. So here you can see different parasitic capacitances are there. So if you have studied MOSFET clearly, so that MOSFET is having multiple parasitic capacitances, right? So it will affect in the frequency response of the MOSFET. So because of the MOSFET architecture, go to the AD and result tools result browser. No, in AD, sir. Tools result browser. Just click on that. Now you can click on that plus sign, plus upper one. Yeah. DC output info. Yes. DC output info. This after DC output. Okay, now here you can see this is an MOSFET, and as you know there are parasitic capacitances like If this is a drain, this is source and gate, okay? So there will be CGD, CGS, right? And there is a body terminal also, right? So drain to body capacitance and source to body. Okay, and as you know, it create a capacitance with the when you operating the MOSFET at that time, the polysilicon which is used for the gate, and there is a silicon dioxide in between, right? And if there is an N plus diffusion like this, so one channel will get created. So this is a polysilicon. This is a silicon dioxide, which is a dielectric, and this is a N-type channel. Okay. So in this also it forms the capacitor. Okay. So for MOSFET, gate capacitance is very important. So MOSFET generally is a capacitor, but we extended that capacitor to work like a transistor. Okay. So different capacitances values are there. So if you observe these parameters here, you can see the different parasitic capacitances are there. Okay. But while you do the fabrication, while you do the metal interconnects, okay, when you are doing the layout, this thing will be more clear to you. So at this point, for the analysis point of view, we will only consider few parameters here. So the first one is GM. So here you can see GM. So GM is a transconductance of the MOSFET. It is very important when you do the amplifier gain analysis. Okay, when you do the frequency analysis, this is a transconductance of the MOSFET. So here you can observe that transconductance value. And as you know, the devices are not perfect, right? Even if you connect the body terminal to the source, there will be the body effect. Okay, what is mean by body effect? This body terminal will work like a fourth terminal. Okay, and it will affect the channel formation which is going on into the N MOSFET. Okay, so which subsequently reduce your threshold voltage of the MOSFET. Okay, that is a very theoretical part, but I'll tell you here. So that body transconductance also is there. Okay, so GEMBS. Is it visible to you, whatever I'm showing? So other parameters are also there, but very important is transconductance, GM. So it is here you can see that is 113.3 microsiemens. Okay. Similarly, you can observe the drain current here. So it is a 0.8 microampere. So first we have seen GM, then drain current, 0.8 microampere. Okay. Now other parameters are also there. Here you can see the R-on resistance. What is mean by R-on resistance? Now if you observe this transfer characteristics, the IV characteristics. So in this region, the MOSFET will work as a variable resistor, voltage dependent resistor. You increase the VDS, what will happen? The resistance value will increase. So it's just like on MOSFET. Okay. So this is a R-on, right? And as you know, there is a channel length modulation effect in the MOSFET. So as you increase the VDS of the MOSFET, drain to source, this channel will get pinch off, right? Because of the high lateral electric field, right? So this channel will get pinch off, and because of that, what will happen? Channel length will get reduced. Okay, so effective channel length will get reduced. So as you know, this is a drain current equation. If effective channel length will get reduced, what will happen? Drain current will increase. So as you see, this is generally happens in the saturation region when VDS is very high. So here you can see for an ideal MOSFET, this will be like a straight line. Okay, so this is like a constant current source. Okay, but because of this channel length modulation effect, this curve will go like this, and that will add R out. Okay, and we will consider that into the AC analysis. So here you can see these two resistances, R on and R out. Okay, so this is also important thing, R on and R out. And next one is region. So here you can observe that region is equal to 2. Okay, what is mean by that? So here they have assigned numbers to the region. So for example, if region is equal to 0, so MOSFET is working in the cutoff condition. If region is equal to 1, MOSFET is working in the triode region or linear region. Okay. If region is 2, it is working in the saturation region. If region is 3, it is working in the subthreshold conduction. What is mean by that? In subthreshold conduction, even if the VGS is less than the threshold voltage, that time also weak inversion layer get forms, and there is a small flow of current through the MOSFET. Okay, so that region is subthreshold conduction, and the fourth one is breakdown. Okay, now if you see this is showing region is equal to 2, means we ended our simulation. We stop our simulator at VDS is equal to 1. So here you can see at VDS is equal to 1. So at this point transistor is in saturation region. Okay, so this is clearly showing that transistor region is saturation region. Okay, so by analyzing this window, you can find out different parameters related to the MOSFET. Similarly, here you can see the threshold voltage of the MOSFET, VTH. Okay, so that is 0.12 volt. So if your gate to source voltage is greater than this, then this MOSFET will turn on. Okay, so this is a result browser use. It's very important when you design any analog circuit or any digital circuit. So to find out the region of operation of the MOSFET and to find out the gain. Okay. So ठीक है then. Close this waveform window. Okay. Okay, close this waveform window. Okay, now you can save your state. You can save your state, means whatever the analysis you have done here, that will be saved. So saved state. Okay. Rahul, you close your waveform editor. Before closing the AD, save your state. Here you can see the option for saving. Save state. No, Rahul, what you are doing? You close this. You close that window, Rahul. Not that upper one. अरे जो मेन विंडो है ना वो क्लोज कर दो. हाँ वही. हाँ राइट. भी वहां पे जो वहां पे एडी है ना, दैट इज एडी इज देयर राइट. एडी विंडो इज देयर ना राहुल.
Yes, sir. Yes, sir.
Yeah, Rahul, you click on this save state, and after doing that, click OK. Okay, and then close this window. Then close this window. Right? अभी एडी क्लोज कर दो आप सेव करने के बाद. Now open your schematic editor. On the bottom side there is a screen. Is everybody following?
Yes, sir.
Yes, sir.
One fellow got disconnected. Yes only. Yes, Rahul. Yes. ठीक है.
Yes, sir.
Okay, ठीक है. Now here you can see instead of VGS, okay, I will give the variable here. I am selecting this DC voltage source, and if I press Q, then instead of 1, I am selecting VGS variable. Instead of 1 only put VGS. हाँ. No, not add an instance, Rahul. Yeah. Click on OK then. Click on OK. ठीक है. Now launch your AD. Now here you can see load state. Observe here, load state. This folder like symbol is there, na? Load state. Okay. So your previous analysis and nodes get added. Now in the design variable window here, the left hand side window is there, design variable. Okay. First click on this, right click. Here, sir. On the left hand side, there is a window now. Here, on the left hand side, sir. Yeah, there. Yes, here, right click, copy from cell view. Okay, now VGS is there, right? So I am putting initial value of VGS 1. Okay.
Now give the initial value 1. Yes.
त्याच्यावर क्लिक करा. नहीं अंदर क्लिक करा, अंदर. हाँ, राइट क्लिक. नहीं, अंदर राइट क्लिक करा. हाँ, कॉपी फ्रॉम सेल व्यू.
लोड स्टेट लेके आना है.
अरे सर लोड स्टेट कर दीजिए. One more thing is there. Make check and save also. Okay. Check and save your schematic. Okay, all of you are up to this point.
All of you check and save and go to it.
Yes,
Now,
sir.
in the design variable section, one variable is get added, that is VGS. Okay, so I have given some value to that 1. Now we are going to perform a parametric analysis. We will change the value of VGS, okay, from 0 to 1. So for that purpose, go to tools, parametric analysis, first one.
Everyone go to the tools, parametric analysis. Puna, go to tools, parametric analysis, first one. Okay, very good.
Okay, now this window will come, right? Now the first option is add variable. So here you can select VGS.
From drop down menu you can find it. VGS will be there, right?
Yes. Again I will show you. Okay, here
drop down menu.
From the drop down menu you need to select it. Here.
Select VGS. Fine.
Okay. So now here you can see from and to is there. So I want to sweep this from 0 to 1. Now here you can see the step mode is auto. So here I can sweep this for 5 steps. Okay. I will, so 5 steps I am putting there because I want a five step in between.
Put the total steps as a 5. Don't click on inclusion and exclusion list.
Okay, no issue, no issue, no issue.
Okay.
So have you done this? Yes. Now you click on this green button, run selected sweep.
Click on the green button, Rahul. Please wait for a while. You can see in your output result there are 5 different values it is plotted because we are taking the total steps of 5. That's why the
Here you can see the IV characteristics of MOSFET. Okay, in the DC response, right? So you can observe like this that so different value of VGS.
yes, you can place the marker and check different value of this.
Okay. So here you can see different values for VGS. So first VGS is 0 and I am getting some current value. Similarly, next VGS is 0.25. So as you know, we have seen the threshold voltage of this particular MOSFET. It is 0.125. While seeing the result browser, we have seen that threshold voltage of this MOSFET is 0.125. For a 0 volt, it is in cutoff condition. So as you increase the VGS, you can observe the change in the current, right? Okay. So this is the IV characteristics of particular MOSFET. Now, if you want to change the background of this particular thing, if you want to change the colors or if you want to change the style of these things, you just need to select this. Okay. Right click here. You can change the color from here. You can change the type. You can change the style also. Okay. Similarly, you can trace the you can change the properties also. Okay, but we have default done that. Now here you can change the foreground, the background of this. Here you can see. It's not showing this. Okay. So now just we have swept our VGS variable. You can sweep width of MOSFET also or temperature also. Okay. So this is a transient analysis. Here you can see the DC current values for a different VGS. Okay, and this is a DC response. Now if I close this, okay, and instead of okay, now I will again keep VGS is equal to 1. Okay, now I'm changing the VGS is equal to 1 and I'm changing, you now close the AD, okay, Rahul, you can close the AD. Now click on this MOSFET, type Q, and instead of total width, put width variable. Only up to 120, yes. Width. Okay. Then click on OK. Again check and save. Now launch ADE. Okay.
Sir, width nano.
No, only width variable you need to select. We need to sweep our width of MOSFET now. So you can observe the effects. Hello, Poonam, what you have done? Have you inserted VGS is equal to 1 volt?
Yes, sir. That part is done, sir.
Okay, and Rahul, what about you?
Where I can do that?
Here you close this. Now you select this VDS, press Q, or you can right click and click on properties. Here you put 1 volt DC voltage. Okay. Now go to the MOSFET part, press Q, and instead of total width, put width there. Instead of 120, put width there. Rahul, first select the MOSFET. So have you selected VGS is equal to 1?
Sir, after MOSFET selection, what to?
Properties. Instead of 120 in total width section, put width variable. Delete 120 and put width. अरे यार पूरा मत डिलीट करो. ओके विड्थ एंड ठीक है. यस पुट विड्थ. व्हाट हैपेंड राहुल?
Rahul, you have written whole width.
Yes, sir.
No, width.
Width, okay, fine. Okay.
Width only.
Yeah.
Okay.
Yes. Now go to AD. Sir, check that he has selected VGS is 1 or.
VGS 1. Then check and save. Check and save. Then go to AD. AD is cut.
Now you can save your previous state.
Load. Okay. Back to AD. Now click here. From cell. Right?
Now click on design variable section. Right click. Copy from cell view. So here I am putting initial width is equal to 1 U. That is mean by 1 micrometer. तेच सर तिथं द्या व्हॅल्यूच्या सेक्शन मध्ये.
सर इसका V नहीं करते V की क्लिक करके V को क्या लिख दे नहीं करते तो वन V की
After making change in your diagram, make sure that check and save, otherwise it will show the error. Okay. Now here up to this point all of you are ready, right? ठीक है. Now, yes. What happened?
Done, sir.
हाँ ठीक है then. Now go to tools, parametric analysis.
Now go to tools, parametric analysis. Are you there?
Here you can select the width in variable section.
On the drop down menu, please find the width. Now,
Okay. Have you selected?
Yes.
Now here you
Yes,
can
sir.
see from and to is there. So I want to vary the width of the MOSFET from 1 micrometer to 10 micrometer. Okay. So I just need to check that in this particular value what current ranges I am getting and which is the optimum one for my design. Okay.
1U to 10U, right?
So I have selected from 1U to 10U, means 1 micrometer to 10 micrometer, and total number of steps I am selecting here 10. Okay.
Mohammed, write the number of steps 10.
So after entering all this value, you can just click on this green button, that is a run selected switches.
You don't run the selected switch button. Okay. Please wait for the. It is running. It will take time. Please wait.
Now here you can see on the left hand side there is a DC response, right? So press V here. You can copy this window to new rectangular window also. So click on this, first click here, then right click. All of you, first click here, then right click, copy to, not there, not on signal. I am clicking here at this point. Yes, click here, then right click. Then copy to new window, rectangular. Okay.
Very good. All of you are getting the output.
Okay. Now here you can see.
You can delete the previous one. You can delete the whole one.
No, not there. Not.
Right?
No need to delete it. ठीक है. So as you see, as you increase the width of the MOSFET from 1 micrometer, from 1 micrometer to 10 micrometers. Okay. So you can observe the increase in the current. So as you have seen the drain current equation, so as you increase the width of the N MOSFET, there will be increase in the drain current. Okay. So generally what happens, if I'm designing a chip for a microprocessor, okay. So as you have seen in the inverter section, we take one PMOS and NMOS, right? So in our microprocessor, what happens, there are different sections like RAM, right, ROM, and other control units are there. Now, all these units sometimes are designed prior or available in the library. So such a kind of designs are called as the standard cells. Okay, standard cells. Okay, so if I'm designing a RAM or if I'm designing a ROM, so for all those whatever the transistor I'm using for building a RAM on ROM, I will keep the channel length same. So what is mean by channel length? If this is a MOSFET, right, and plus. Okay, so this is a P-type MOSFET, right? N-type MOSFET having P substrate. So this part is polysilicon. and this part is silicon dioxide, and these are N plus diffusions, right? And then we connect drain and source to the metals for these diffusions, okay? And here we connect the gate. Okay, so now this thing is called as the length of the channel. So if I am saying that this particular chip is having the technology 10 nanometer, so they are talking about this length, okay? The length of the channel, and this will be the width of the channel, okay? So as you know, this drain current is depend on this physical dimensions, width and length, okay? So whenever you change this parameter, there will be change in the current, and there will be the change in the performance of the MOSFET, okay? So what we are saying here, so as we increase the width, here you can see as we increase the width, current flowing through the MOSFET will increase. So here you can see the current is increased from, like, here you can see that is from 502.63 microampere to 4.8546 microamperes. Okay, so like this way you can analyze your MOSFET, or you can analyze your design. I have shown with the simpler design. You can do the parametric analysis for any complex design. Okay, if you want to do the analysis for more than two variables. Okay, so for all step is same only, but design will get changed. Okay, so this is all about the parametric analysis of N MOSFET. Okay, ठीक है. So are you getting this point? Do you have any doubt? You can ask me. Yes, yes. I will show one more analysis. Okay. Are you getting the point? Do you have any doubt?
No, sir, no doubt.
No, sir.
So you can vary any parameter. You can just the
sir.
characteristics of this graph. And we have varied the 2-3 parameters like VGS, VDS, as well as width we have varied.
You can also change for temperature also.
You can change for temperature. Please try by your own. You can go for, in the same way, you can go for change for the temperature also.
Okay. Now, so all of you, what you do in the same library, you do this analysis for P MOSFET. Okay. So in the P MOSFET, what will happen? The VGS will be negative. Similarly, VDS will be negative, right? So these two DC component will be negative. So in the schematic, you need to connect DC sources in that way. So that is your task to do the parametric analysis of P MOSFET. Okay. Whatever the analysis we have done here, you need to follow the same thing for the P MOSFET. So I can.
You can close this and you can, in the same library, you draw for the PMOS.
You can close this, and the same library you can do that thing.
Only you have to create the cell view lane. Rest all process is the same. You can save your state and close this ADL window. State of the server. Just need to create.
नाही सर, ते AD मध्ये आहे. तुम्हाला वेवफॉर्म सेव्ह करायची आहे का? सेव्ह इमेज जा, फाईल सेव्ह इमेज. सेव्ह इमेज खाली आहे सर्व. खाली खाली प्रिंटच्या खाली. हो. हां, तिथं नाव द्या इमेजला. आणि तुम्हाला जर प्रिंट काढायची असेल ना, त्याला वाईट बॅकग्राऊंड करा, नाही तर हो नाही व्हाईट बॅकग्राऊंड करायचं, त्याला व्हाईट बॅकग्राऊंड करता येतो असं. इथं जा, राईट क्लिक आहे ना तिथं.
Yes, Rahul, are you there?
Yeah.
Rahul, are you there? Yes. Okay, just close that and go for the CMOS. कुछ टास्क दिया है सर हाँ उसी में रिप्लेस
साठी करा सर.
देखिए गलती हो सर इसमें रिप्लेस करा टीमोस हाँ हाँ दीजिए हम
Don't do in the same diagram, okay? Don't do in the same schematic editor or same file. You create a separate file, okay, Rahul?
Okay, sir.
Now what will happen? If the instances name will be it's just like a language, okay? You can write a VHDL or Verilog code for this also. So it is converted into nest list. Otherwise, it will give you error.
CMOS के लिए चाहिए और इसमें नहीं चाहिए सर CMOS इसमें
Rahul Poonam, you are not performing anything.
Yes, sir. Doing it.
It's not visible here on screen.
Sir, I'm not able to rotate.
You are not able to rotate.
Sir, yes, sir. VGS negative we have to attach, no?
Yes, VGS should be negative and VDS also should be negative. But make sure that your source terminal is the upper terminal, not bottom one. Bottom one is a drain terminal. जो अपर का टर्मिनल है वो सोर्स है, ओके, बॉटम को मत कनेक्ट कीजिए.
Yes, sir. CMOS है ना?
यस PMOS. तो गेट के सोर्स के बीच में डीसी वोल्टेज लगाओ ना, ड्रेन को कैसे लगाओ? ठीक है. Source to drain is also required, Mohammed. You are right, Mohammed. Source to drain is also required, but that VGS should be between gate and source, no?
Yes, sir. I have connected it down.
Okay. Just make the proper connection. Now, can you tell me IV characteristics for PMOS is in which quadrant? ID versus VDS characteristics. Can anyone tell me which lies in
Sir, second
which
quadrant.
How?
Sir, VGS is negative.
No. The y-axis is VDS, no? Drain to source voltage, and x-axis is drain current,
ID.
right?
Yes.
So ID will be negative and VDS will be?
Sir, it will also be negative, na sir?
Yeah, right. So which quadrant?
Third quadrant.
Good. So you just made one mistake that connect that source between that gate and source. Now the upper one terminal is source. So gate, the voltage, DC voltage you have connected. Okay. So that should be between gate and source, the upper one.
VDS, sir.
No, on the left hand side there is a VGS. No.
Yes. VGS.
So source is your upper terminal, not a bottom one.
Yes.
So that DC voltage should be between those two terminals.
Right, sir. Right.
So that is basic only. Okay, Rahul. Connect your that source DC voltage, input voltage between gate and source. The source terminal is the upper one, okay?
Okay,
So
sir.
you have connected that between gate and drain, right?
नहीं
सर इथं काय करायला लागेल हे बरोबर केलं काय सर
अजून तुम्ही एक चूक केली. काय केलं तुम्ही? गेट आणि ड्रेन डायरेक्ट शॉर्ट करून टाकले.
गेट आणि ड्रेन
हा,
हां
ते शॉर्ट नाही करायचे, ते काढा. गेट आणि ड्रेन मधलं काय? हो.
वाह ठीक आहे सर ठीक आहे घेतलं ना
Okay, Mohammed, you are getting means have you selected drain terminal or source terminal? Maybe you have selected source terminal, right? So this is your source current, okay? And so you need to select a drain current.
वेट कीजिए ठीक है पूछिए डॉक्टर साहब
Drain current means the bottom one terminal is the drain. So you need to select that bottom terminal. Select that one. Delete. No. Yes. Yes. Now it will show in the setting outputs. Yeah, right one. Now one more mistake you have done here. You can save this state. You just try to identify that mistake. That is about the VDC source, okay? The output VDC source. For a P MOSFET, VSD should be positive and VDS should be negative. Okay, so source terminal is topmost and drain terminal is bottom one. So have you understood your mistake? VSD should be positive, VDS should be negative.
Yes, sir.
Hmm.
Newton है सर आपका.
Okay, time is running out. Just do fast.
Sir.
Hare Mohammed. So in this, your VDS is there, na? You have selected VDS variable, but that should be
Yes, sir.
selected as a DC sweep variable when you select a DC component for sweeping, because
Okay, sir.
whatever the variable we require as a x-axis, that should be selected as a sweeping variable in a DC response sweep variable analysis, and your VGC should be selected sweep variable in the parametric analysis.
Okay, sir. So first I have to select VDC as a variable, sir.
No, VDS not as a variable. You can put VDS some value there, and you can choose VGS as a
VGS
variable.
Variable. Okay, sir. Okay.
अभी जो ड्रेन टर्मिनल तू सिलेक्ट करेगा ना, तो वो नीचे वाला ड्रेन टर्मिनल है, उसका करंट मेजर करना है तो वो नोड सिलेक्ट करना पड़ेगा. ओके.
हाँ सर, हाँ सर.
हाँ, तो आप सही कर ले.
बाकी लोग रुकिए, जल्दी करना हो रही.
नहीं, वो नहीं, वो VDS वाला सिलेक्ट कर लो. हाँ, सही है. ठीक है. वैल्यू दे दो अभी।
ओके सर।
या अभी अभी ये पैरामीट्रिक एनालिसिस कर लो VGS को,
यस सर।
डिजाइन वेरिएबल में पहले लोड कर लो। हाँ, उसको सब इनिशियल वैल्यू दे दो अभी।
यस सर।
हाँ, अभी पैरामीट्रिक एनालिसिस कर लो उसका। हाँ, सही आ गया। अभी क्या है इसमें जो आपका VDS है ना, VDS वो जो आपका ये है ना, मतलब वो पॉजिटिव लिया है ना आपने, तो वो इसलिए वो पॉजिटिव दिखा रहा है वो VST, राइट?
आई थिंक सर फोर्थ क्वाड्रेंट में प्लॉट कर दिया इसने अभी।
या वही ना।
हाँ
ड्रेन
वो
करंट तो निगेटिव दिखा रहा है, बट अभी क्या है, सिमेटिक
VDS।
दिखाओ तो, सिमेटिक दिखाओ तुम।
ओके सर। हाँ ये पॉजिटिव हो गया सर।
हाँ, ये जो है ना, अभी VSD दिखा है, विथ रिस्पेक्ट टू VSD दिखा है ना उसने।
हाँ हाँ हाँ।
समझ में आया क्या?
यस सर।
हाँ, अगर तुझे मतलब उल्टा मूव करना है तो कैसे करेगा तू? ऐसे ठीक है, वैसे भी सही है, ऐसा कुछ नहीं। वो जो वेवफॉर्म विंडो खोल ले, वेवफॉर्म विंडो खोल ले अभी।
ये वाला
और
सर।
हाँ, वो एक्सिस पे जाओ और DC वोल्टेज के एक्सिस पे जाओ।
यस सर।
हाँ, तो उसको VSD पुट कर सकते हैं आप फिर वहाँ पे एक्सिस प्रॉपर्टीज में जाके।
प्लीज।
हाँ, इसको वो डिफॉल्ट को अनटिक कर लो और वहाँ पे VSD पुट कर दो अभी। तो
ओके
वो
सर।
समझ में आएगा ID वर्सेस VST है, इसलिए वो ऐसे प्लॉट कर रहा है। VSD तो अपना पॉजिटिव होता है ना।
यस सर। यस सर।
हाँ हाँ हाँ, गुड।
ओके।
हाँ, now I will make you presenter. You just explain to other participants to how you have means just explain the design, okay? I will make you
सर
the
एक्चुअली
presenter.
सर आई हैव जॉइंड फ्रॉम माय मोबाइल फोन एंड आई एम डूइंग इट ऑन माय लैपटॉप सर।
Okay.
हाँ वो लॉगिन करना पड़ेगा सर वो।
तो लॉगिन करने में कितना टाइम जाएगा?
सर वो पासवर्ड सेव नहीं है ना सर, वो टाइम लगा रहा है,
अरे
फिर
यार।
मोबाइल में से लेना पड़ेगा।
ठीक है। अभी अपना जो डायग्राम है ना, उसका
यस सर।
उसका डायग्राम का स्क्रीनशॉट और वेवफॉर्म का स्क्रीनशॉट चैट में डाल दो, वो तो कर सकते हो क्या? नहीं?
यस यस सर। हाँ सर
हाँ,
कर दे।
तो अदर पार्टिसिपेंट कैन सी द डायग्राम।
यस सर।
हम्म।
बट सर वो स्टिल अभी फोर्थ क्वाड्रेंट में ही बता रहा है एक्सिस
हाँ,
चेंज करने के बाद भी।
नहीं नहीं, वो क्या बता रहा हूँ मैं, वो VSD के रिस्पेक्ट टू ड्रॉ किया है ना उसमें।
यस सर।
VSD पॉजिटिव है मतलब VDS निगेटिव है ना। समझ में आया क्या?
यस सर आया।
हाँ हाँ, वैसे VSD पॉजिटिव है।
ओके सर।
ठीक है, इसका स्नैपशॉट और डायग्राम का स्नैपशॉट करके इसमें डाल दो चैट में।
यस सर। हाँ सर। यहाँ से डाल।
You have also done, right? Yes, Rahul and Poonam, you have also drawn the correct diagram. You just do the analysis then, okay? You select the VST 1 volt, okay? And you keep a VGS variable. You keep VGS is equal to VGS. DC voltage of VGS should be variable, okay? You just need to make those two changes. And by selecting the AD, what happened? What error you got? Roll number 3, what error you got?
Sir, that line is blinking, sir.
Line is?
I will, sir, I will do check, sir.
Okay, you delete that solder dot. There is a dot get created in that diagram. You click on that and press delete button on your keyboard. That way also you can delete that. Yeah, right. Yes, delete it.
Sir, not going, sir.
Okay. हाँ ठीक है अभी अभी कर रहे Please wait. Sir is operating your tool.
Yes, it is not deleting. Let me check it once. Okay, no problem. That's only the warning. That will not create much problem. You can go forward.
Okay, you can neglect the warning. There is no issue with the warning. Okay. What you do, you keep VDS VSD is equal to 1 volt. Okay, and the DC voltage for gate to source should be VGS variable. Okay.
This one is VGS.
How we have selected VGS variable, like that way you need to select VGS.
So this we have to put VGS.
Yes. And select the last one, that VSD should be 1 volt. And while selecting the analysis, you just need to make that in the DC response, you just need to make that VDS sweeping variable, okay, of DC. So you need to select that component.
VGS.
Yes, VDS, DC voltage. Yeah, you select the node. You need to select the bottom one, drain node of MOSFET. Drain node of the MOSFET. Yeah.
Okay, we'll select. We'll delete all those. Drain node, copper node. Okay. Sir.
हाँ सही में अभी इसके लिए पैरामीट्रिक एनालिसिस कर दो सर. टूल्स पैरामीट्रिक एनालिसिस. हाँ अगर आपको कोई डायग्राम वगैरह सेव करना होता है तो कैसे कर सकते हैं, दिखाता हूँ मैं एक बार। Now, if this is the diagram, right? So I can go to File and Save Image. From here, you can change the image, and you need to replace the background with the white if you want to. So, like that way, you can do. You can save the image.
All are overlapping the same point. I think we have done some mistake there.
Okay. So, like this way, you can save your image. Okay, waveform. Similarly, the schematic.
Making some overlap. हाँ उधर नीचे से करवा लेना था क्या? नोट स्टिकर में क्या था? इधर कौन करना है? आला कहीं भी जाके रखता है
नहीं क्या किया इसमें दोनों डायग्राम की
इसमें नाम कैसे क्यों नहीं आ रहा भाई क्या है हाँ यही है फिलहाल जो किया टाइम नीचे क्या ऑन है नहीं अभी तो नहीं है
लॉग में जाके
16 से क्या है ये 16 से क्या है इसी टाइप का ये 16 14 यही है बस सब लिखके बोला और बहुत सारे मल्टीपल टाइप खोली वो बस है छोड़ ये सब कलर बुलाते हैं उसको
ठीक है, we will see this tomorrow. Okay.
we'll see this tomorrow we will leave this meeting as the time is over it is already 4:15 you can disconnect okay
Okay, we can conclude this lab session here. Okay. So whatever the errors you have done there, we will see tomorrow. Okay. You can practice those things tomorrow. We can conclude this lab session here. Okay. Thank you for attending.
Thank you, sir. Thank you, sir.
Yes, welcome.
stop video